Pipe bursting. Pipe bursting is one of the methods of construction PW Trenchless has specialised in the last 20 years. It's a bit of a hybrid because we're using the existing pipe as a guide to install a brand new pipe. So it's a hybrid between rehabilitation and new pipe construction. Diameter is anything from 25 millimeters, like a water service into a house, all the way up to 1200 millimeters is the biggest we've completed so far. Again, because you're dragging pipe through the ground, you're limited to about 150 meters in length in total. It can either be static or pneumatic. Pneumatic systems are favoured in the southern half of the US. Static systems tend to be favoured in the north half of the US and most of Canada. So pneumatic systems it's an air-powered system with a hammer inside in the head, and it essentially hammers forward and pushes the material out of the way through the hammer action of the hammer inside the bursting head, and there's a cable in front that just gently guides the hammer forward so that it doesn't go offline. Static systems, there's a rod system used to grab the head, which is a dumb head if you want it. There's nothing in it, just a cone, and the rod system pulls the head through the ground, and that causes the ground to be displaced and the existing pipe broken up and the new pipe pulled into place. Typical pipe bursting parameters. Well, the normal upsize that we have are two to three sizes up, and that's the regular. We can use pipe bursting when the pipe is too small. We can use pipe bursting when the pipe is partially collapsed. It is one of the benefits of pipe bursting. Lots of times if the existing pipe is collapsed, we can't use a lining system, and we can't use a lining system, we can't use a slip line system. So pipe bursting does help that. Or if we've got offset joints, we can use pipe bursting to just eliminate the existing pipe and bring a whole new pipe into place. Typical pipe bursting situation. You will see on this one here that the head on this one is a dumb head. It's got a rod system on there, and it's going to get pulled into place. This, I believe, was in New Westminster a number of years ago. You can also notice that the size of the excavation is quite limited. We need to excavate probably about 10 to 15% of the road to install a pipe versus 100%, of course, with an open cut scenario. Again, you see here in a typical New Westminster job, it's in the back alley of New Westminster. Again, we're doing, so about 90% of the ground is not excavated. So we're doing 1.5 meter pits every 20 meters, and then the exit and entrance pit. Here's an example of a large diameter pipe burst. This was a job that was in North Vancouver, 2017. It went from 1040 to 1200 diameter. So not a big upsize, but a big size, a large diameter. That was a static machine we used in that one. The problem there was a corrugated steel pipe. It had decayed over the years with seawater coming into it. It was full of debris from the local mills, and they didn't have the ability to clean it out. And so the whole storm sewer system on the bottom of Pemberton Avenue in North Vancouver wasn't functioning. They had to use bypass pumps for years until we were able to come up with this and do this option. Here is a job that we did about 4 years ago in Maple Ridge. It was actually a record for North America at that point. We went from 375 millimeter pipe up to 950 millimeter pipe. That was five pipe sizes up, or 6.5 times the increase in cross-sectional area. Phenomenal job to upsize that much, and took a lot of effort. You will notice here we have 3 different expansion cones and 3 different segments of straight pipe. What we were doing with that is expanding the ground, and of course when you contract the ground, you raise the pore pressure of the soils quite substantially. So that would be done by the cone, and then the flat section would allow that pore pressure to stabilize a little bit, and then we get hit by the next cone, which would again increase the pore pressure, and then relax again, and then do the final pull in. That's the reason for the 3 cones. And here's the other extreme of pipe bursting. A long time ago, as you can see the asbestos pipe, this was back in the 90s, and no high-vis jackets on at that point. Just doing a house lateral in West Vancouver back in the 90s. Just 100 millimeter pipe. That was with the cable system, just a static system at that point, a little cable system. Cost comparisons. A lot of people ask me if trenchless technology in general is much more expensive. Most of the time it's not. CIPP is probably 40 to 50% of the cost of open cut. HDD is 50 to 60% of the price of open cut. And pipe bursting in general is about 75% of the price of open cut. Now those generally, remember, CIPP, horizontal directional routing, and pipe bursting have fairly fixed costs at both ends, because you've got to do the pits, the entrance pit, the exit pit, the pipe fusion, and so on. And so the longer the run becomes, the more cost effective they become. If you've got to do 2 pits and you're doing a 20-meter run, obviously pipe bursting and or CIPP are not going to be that effective. Slip lining, pipe ramming, pipe jacking, those are generally being done under railways, highways, where you just do not have the option of excavation, so you can't do anything else.